Great, so today we're doing 3-5 systems with 3 variables. Again, still in 3-5, except this is substitution, so we're using a different method. The voice might not be the best from over here, but this is what we're going to go with today. So in substitution, we're still doing the same thing. We're trying to find the ordered triple, the x comma y comma z, that's going to make all 3 of these work. Right, so we're still looking for that x comma y comma z. But in substitution, we're going to substitute. So usually on these problems, you'll find one of your equations is a little bit shorter. So you can see how this third equation just has y and x. So that's the one we're going to substitute for. So since it's already solved for y, we're going to go ahead and substitute that in for y in the other 2 equations, right? We're going to substitute in for y. So like the first one, we'd have, negative 5x plus 3 times y is negative 2x plus 8, still minus z, still equal to negative 28. I'm just going to take up the room over here. And then the second one, we have that negative 5x plus 2 times y is now negative 2x plus 8. And that's equal to negative 29. So the first step is to solve one of the equations for one of the variables. So that third equation was already solved for y, so I went with it. And then I'm substituting into the other 2 then equations what y was equal to. So now I'm going to simplify here. So I've got negative 5x minus 6x plus 24 minus z equals negative 28. Then I'm going to combine my like terms. So I've got negative 11x. I've got my minus z plus 24 equals negative 28. So when I take that 24 over to the other side, I'm sitting at negative 11x minus z equals negative 52. All right, so then I'm plugging in y to the second equation. I already wrote it out here. So I have negative 5x minus 4x plus 16 equals negative 29. So when I combine my like terms, I get negative 9x plus 16 equals negative 29. Taking over that negative 16. Ooh, this is nice. Negative 9x equals negative 45. What's great about that, this one has a little shortcut. Because now I can solve for x by dividing by negative 9 and find out that x is 5. So there's a little shortcut hidden in that one. Usually what happens is you have to create a system. Just like on this first equation over here, we had an x and a z, but we lucked out, and here we ended up with just an x. So now I can plug that 5 in. My equation here that has 2 variables. So let's see, negative 11 times x is 5 minus z equals negative 52. So negative 55 minus z equals negative 52. When I add over 55, I'm at negative z equals, let's see, that'd be 3. So then when I divide by negative 1, z is negative 3. So now I'm looking for, I have x, right? I just found out that x is 5. I know that z is negative 3. So I'm looking for y. So I have to pick an equation that has y. That one looks nice and little and sweet. So I can do y equals negative 2 times x is 5 plus 8. So y is negative 10 plus 8. So y is negative 2. So my ordered triple answer on that one would be 5, negative 2, negative 3. So that's the substitution method, right? You start the problem off by substituting. All right, let's look at number 2 here. So on number 2, I'm going to scratch out number 1 so I don't look at it. Number 2, even though the top one is solved for y, I think I'm going to go and solve the bottom one for x because it only has 2 variables, right? It only has 2 variables. I'm going with x instead of y because if I solved for y on the bottom one, I'd have to divide by 4. Dividing by 4 is going to give me some decimals I don't want to deal with. But if I end up on dividing here, I get 2x equals negative 4y plus minus 22, my bad. I end up dividing by 2. I know that since those are both even, I'm not going to have decimals. So I get x equals negative 2y minus 11. So first step, solve one of the equations for one of the variables. Even though the top one was already solved for y, I went with the bottom one because it only had 2 variables. Seemed like less work. So now, since I solved the bottom one for x, I have to substitute in for x into the other 2 equations. Right? So top one would be, I'll go over here, y equals, the new x is negative 2y minus 11 minus 4z plus 3. So let's see, in cleaning it up, I want to take my y to the other side, and I want to take my z to the other side. So let's see here. Oh no, I hate when that happens. So I added over 2y, and I added over 4z. So I'm sitting at 3y plus 4z equals negative 11 plus 3 is going to be negative 8. All right, then I'm going to plug that x value into the second equation. So we have 2 times x is negative 2y minus 11. I can't read it there. Okay, so minus 2y minus z equals 1. So I distribute, I get negative 4y minus 22, still minus 2y minus z equals 1. Combining like terms here, I get negative 6y minus z equals, I add that negative 22 to the other side, so 23. So here we are then with our 2 equations, and we go through elimination just like we did before. Right, so these are going to be our 2 equations. So I can either go for opposite y's or opposite z's. Kind of a toss-up here. I'm going to go with the y's. The opposite of negative 6 is positive 6. So I can multiply 3 by, it doesn't like when I do that, 2. So 2 times 3y gives me 6y. 2 times 4z gives me 8z. So the rest of the problem is very similar to elimination yesterday. 2 times negative 8 is negative 16. Bottom one staying, negative 6y minus z equals 23. So when I add them up, y's are gone. 8z minus z is 7z. Negative 16 and 23 would be 7. So then 7 divided by 7 is 1. Now that I know that z is 1, I can go back down here to either my green or my red and figure out what y would be. I'll go with the green one over here. So now that I know that z is 1, I can replace 1 in for z. So I'm looking at 3y plus 4 equals negative 8. When I subtract 4, 3y equals negative 12. When I divide by 3, y equals negative 4. So I know I'm looking for the ordered triple, x comma y comma z, right? So I know that y is negative 4. I know that z is 1. So now for x, I have to just pick one of the equations that has an x in it. I'm going to go with this blue one here. So x equals negative 2 times y is negative 4 minus 11. So x equals 8 minus 11. So x is negative 3. So my ordered triple answer would be negative 3, negative 4, positive 1. So the big difference between the elimination and the substitution method, because like the middle and the end are pretty much the same, is the elimination, you start by eliminating, not to be ironic, and in substitution, you start by solving one of those equations for one of the variables and substituting. Have fun.